All right, welcome back. Today we're diving into something pretty exciting that's been making waves online. If you follow next-gen aircraft development, you've probably seen it, this almost 2-minute video of China's J-36 stealth fighter actually flying.
Yeah, it surfaced on Chinese social media, and it's definitely caught people's attention.
It really has, because, before this, we've only had these really short, kind of fleeting glimpses. So getting nearly 2 minutes of footage, that's a big deal for understanding what's going on with this plane.
It absolutely is a really significant development. So today we're going to dig into this video using some of the analysis floating around, like from the text you shared. We'll try to figure out what it tells us about, well, how far along the J-36 is, how mature the design looks, and crucially, how it actually handles in the air.
Right. And the mission for you listening, we want to cut through the really technical stuff, pull out the key insights, basically give you the shortcut to understanding why this video matters so much.
Exactly. No need to get bogged down in jargon. Let's just get to the heart of it.
Okay, so let's start with the length. Almost 2 minutes of continuous flight. That's, like you said, way more than the few seconds we had before.
Yeah, and that continuous footage gives us a proper chance to actually observe its flight behavior, not just a quick pass.
So what are we actually seeing in those 2 minutes? Is it just flying straight and level?
No, not at all. The analysis points out this wasn't just, a simple takeoff and landing circuit. It's performing what look like quite clean, deliberate maneuvers, and at a pretty low altitude, too.
Low altitude, okay.
And what's really striking, according to the source material, is how smoothly it seems to be doing it. There's no obvious hesitation, no visible struggling with the controls, no hint of instability. It looks controlled.
So not just proving it can fly, but showing off a bit. An active performance, as the text puts it.
You could say that, yeah. It's definitely more than just basic airworthiness testing, it seems. And this is where it gets interesting when you think about the aircraft itself.
How so?
Well, think about the size. It looks visibly larger than China's other stealth fighter, the J-20. It's got that really broad, tailless, flying wing shape. You'd normally expect that to mean, maybe less agility, more focused on payload and range.
Right, like a bomber or something less nimble.
Exactly. But this video shows it banking pretty sharply, executing controlled turns, seemingly at decent speed. That kind of agility for an aircraft of its apparent size and configuration is, well, it's noteworthy.
Okay, so that apparent agility is key. And it ties into how China's showing this off now, doesn't it?
It does. There's a definite shift. We went from those very limited, static, carefully controlled ground shots or super brief clips to this. It feels, as the analysis suggests, like they're deliberately letting the aircraft, speak for itself a bit more now, showing its maneuverability.
Design of confidence, maybe.
That would be a reasonable interpretation, moving beyond just a shape, a silhouette, to demonstrating actual flight characteristics.
Which brings us to the really big question. Technically speaking, how is it doing those sharp maneuvers? Because, like you said, it's big, it's tailless, it doesn't have those usual tail fins, the elevators and rudders that planes use to turn and pitch. So, conventional aerodynamic controls alone, it seems like they wouldn't be enough for those sharp banks we're seeing.
That's the core puzzle, isn't it? And the most likely answer, the one the analysis strongly points towards, has to be thrust vector control, TVC.
Okay, TVC. Let's quickly unpack that for everyone.
Sure. So basically, instead of the engine exhaust just blasting straight out the back, TVC means the nozzles, the bits where the hot gas comes out, can actually pivot or redirect that thrust, angle it up, down, maybe even side to side.
Gotcha. So the engine thrust itself helps steer the plane, not just the wing surfaces, like an invisible rudder made of jet exhaust.
That's a great way to put it, yeah. It gives the aircraft extra control authority, especially over pitch, nose up, nose down, yaw, nose left, right, and roll. And crucially, it's really effective at lower speeds or high angles of attack, times when traditional flaps and ailerons might lose some of their bite.
And for a tailless design like the J-36.
Exactly. For a big, tailless flying wing, TVC goes from being just a performance enhancer to being almost essential for controlled, agile flight, especially the kind of sharp turns seen in the video at lower altitudes. Trying to do that just with wing surfaces would be incredibly difficult, maybe unstable.
Like trying to steer a canoe quickly using only tiny paddle adjustments?
Something like that, yeah. You need a more powerful way to change direction. And the J-36's design with those big engine nacelles integrated smoothly into the back looks like it's built to accommodate TBC nozzles.
The analysis also mentioned some hints about the engines themselves, right? Something about a possible triple engine setup.
Yes, that's floated as a possibility based on some interpretations of the intakes and fuselage shape, maybe two main engines and a smaller third one, perhaps an auxiliary power unit or related to a specific intake design. It's speculative, but
the performance we see, the way it moves, definitely suggests powerful engines.
Oh, absolutely. The analysis highlights that. The aircraft's movement implies a strong thrust-to-weight ratio. You see hints of afterburner effects, that characteristic glow from the nozzles, and the control inputs seem smooth, indicating a high-performance, responsive power plant.
And you mentioned something earlier about the appearance of the nozzles being a clue, that they looked clean and flush.
Right. This is quite interesting. So many TVC systems, especially older ones, use fairly obvious mechanical actuators, sort of like paddles or complex moving parts around the nozzle exit to redirect the flow.
Okay.
But the text notes the J-36 nozzles in this video appear quite clean, integrated smoothly. This could hint, and it's speculation still, that they might be using a more advanced, perhaps less mechanically complex form of TVC.
Like what?
Things like fluidic thrust vectoring, which uses injected airstreams to steer the main exhaust, or perhaps throat skewing mechanisms inside the nozzle. These can be harder to spot visually and potentially better for maintaining stealth.
Because fewer moving external parts means a cleaner radar signature.
Potentially, yes. That's the theory. It would align with the overall low observable goals of a stealth aircraft.
So this isn't just happening in a vacuum. This J-36 test flight, this video, it fits into China's bigger picture for military aviation.
Definitely. The source material frames it exactly like that. This is part of a major push into what they see as sixth-generation fighter capabilities. Every bit of information we get, like this video, helps narrow that gap between the concept drawings we saw years ago and something approaching a real operational capability.
And it's not just about being stealthy anymore.
No, it seems the goal is aerial dominance, which requires not just stealth, but also advanced controls, sensor fusion, networking, and yes, agility. If the J-36 genuinely has effective TVC, well, that puts China in a very small club of nations that have mastered integrating that onto a stealth platform.
A very exclusive club indeed. So looking ahead, what should we be watching for in future flights or videos if they emerge? How can we get more confirmation on this PVC capability?
Well, the analysis suggests keeping an eye out for more demanding maneuvers. Things that really push the flight envelope and rely heavily on advanced controls.
Wow.
Maybe things like sustained vertical climbs, demonstrating raw power and control, or controlled, maybe even flat, spins recovery. High angle of attack flight, flying with the nose pointed way up and maintaining stability. These would really stress test the TVC system and the flight control software.
We'd also be looking closely at the nozzles themselves during these maneuvers.
Absolutely. Any visible changes in nozzle shape or angle would be telling. Also, any signs of fuselage panels opening or changing shape, maybe related to weapons bay testing or sensor deployment. Each new clip is like another piece of the puzzle.
It really feels like this video marks a kind of turning point, doesn't it? The way the source text describes it, moving from a mysterious silhouette to something showing real tactical capability.
I think that's a fair assessment. It's a more dynamic, confident display than we've seen before. And again, the implication of advanced propulsion control, likely TVC, is huge. Mastering that tech is a major step.
And it seems to be happening relatively quickly.
The pace of development, moving from just models and rumors to these kinds of flight demonstrations, is certainly something observers are noting.
Speaking of models, the analysis also brought up something else interesting, these detailed scale models of the J-36 that have shown up recently in China.
Ah, yes, that's another significant piece. These aren't just crude desktop toys. They seem quite detailed, potentially offering real clues about the internal layout.
What kind of clues?
Well, one of the most talked about features is the cockpit. The models apparently show a side-by-side two-seat configuration.
Two pilots. Interesting. What does that usually imply?
It could mean several things, maybe dedicated roles. One pilot focuses on flying, the other on managing complex weapons systems or sensors. It could be for advanced training, or potentially one crew member acts as a sort of mission commander, managing drones or other assets. A two-seat configuration often points to a multi-role capability beyond just air-to-air fighting.
And the models also showed off the fuselage size.
Yes, they really emphasize how wide the fuselage is. And the analysis connects this directly to accommodating what's described as a massive internal weapons bay.
Which is crucial for stealth, right?
Yeah.
Carrying weapons inside keeps the radar cross-section low.
Precisely. If it can carry a significant load of air-to-air missiles or maybe even air-to-ground precision weapons internally, that's a major capability. You get both stealth and hitting power.
How detailed were these models regarding the weapons bay?
Apparently quite detailed. The text mentions clear depictions of the weapon bay doors, the internal structure, even mounting racks that look sized for multiple missiles. There were even markings suggesting locations for hydraulic or electronic access panels. It suggests a level of design finalization, at least for the model maker.
So putting the flight video and these model details together, what's the picture that emerges?
It suggests the J-36 might be aiming for this quite potent combination. Stealth characteristics, high agility, possibly enabled by TVC, and a really substantial internal weapons load. That blend, as the text notes, is actually quite ambitious, even for sixth-generation concepts.
Okay, so summing things up for listeners.
Yeah.
We've covered a lot of ground based on this new video and the models. What are the absolute key takeaways?
I'd say three main things. First, the flight itself, nearly 2 minutes showing clean, deliberate, agile maneuvers. That suggests the program is well beyond basic testing. It looks capable.
Right, point one, impressive, confident flight performance.
Second, the strong indications of thrust vector control. The agility shown, especially for a large, tailless design, makes TVC seem almost necessary, and the analysis leans heavily that way. That's a major technological capability.
Okay, point two, TVC seems highly likely, enabling that unexpected agility.
And third, the combination of the flight demo and the detailed scale models points towards a potential design philosophy, a heavy payload stealth fighter. The large internal weapons bay, suggested by the models, combined with the demonstrated maneuverability, paints a picture of a potentially very formidable aircraft.
Got it. Point three. Evidence points towards a stealthy design potentially carrying a lot of weapons internally.
Those seem to be the core insights emerging right now.
So it's moving quickly, integrating advanced tech, potentially aiming for a potent mix of stealth, agility, and payload. It definitely leaves you wondering, considering this apparent progress, what might be the next big leap we see in stealth aircraft tech? Maybe something we aren't even anticipating yet. And how could that change the game in the skies?
That's the question, isn't it? Something to keep watching.